In this video, we're going to discuss the convergence or divergence of the series k equals 1 to infinity, k plus 1 over k cubed plus 2. Now, one thing to think about, as k gets really large, the 1 and 2 really aren't going to make a difference. So k plus 1 over k cubed plus 2 is going to be very close to k over k cubed for large k. Large values of k. Well, then what we're going to do is we're going to set up a limit comparison test. We're going to let this guy be our a sub k, this guy be our b sub k, and we are going to do the limit as k goes to infinity of that ratio. So, this is one way of testing how similar two numbers are. If this goes to a finite number, then they grow at about the same rate. So I have k plus 1 over k cubed plus 2 over k cubed. And I'm going to probably should write limit as k goes to infinity. We have not taken the limit yet, so we should have that in on every step. Limit as k goes to infinity. Here, I'm dividing by a fraction, so I can flip and multiply. So I have k plus 1 over k cubed plus 2 times k cubed over k. We'll go ahead and multiply, and we'll do a little bit of simplification. So limit as k goes to infinity of k to the 4th plus k cubed over k to the 4th plus 2k. Now, some of you guys might know what this limit is already. Let's go ahead and pretend like we didn't and see how we could figure it out. Well, notice what I have. If I plug in, as these go to infinity, I've got an infinity over infinity case, which allows me to use L'Hopital's rule. I always like to put an h over my equal sign to denote that I'm using L'Hopital's rule. So I'd go ahead and take the derivative, and I get 4k cubed plus 3k squared over 4k cubed. Alright. Doesn't quite give me the limit, but if you notice, I do have another infinity over infinity case. I'm going to use L'Hopital's rule again. So limit as k goes to infinity. And so what I get is now 12k squared plus 6k all over 12k squared. Once again, I get an infinity over infinity case. Applying L'Hopital's rule again, I get the limit as k goes to infinity of 24k plus 6 all over 24k. You probably notice those first terms keep coming out the same. We know from our study of rational functions that there's a horizontal asymptote here. We're just going through the steps of showing it. I've got an infinity over infinity case again. Applying L'Hopital's rule one more time, I got the limit as k goes to infinity of 24 over 24, which is 1. And I see that my limit is 1. Came out to be a non-zero finite number. That tells me that these grow at about the same rate. Now let's see how we can use this fact for our purposes. Well, let's think about what we know about this series, k over k cubed. That can be reduced down to the 1 over k squared. We know this is a p series with p greater than 1, so this converges. So we can actually conclude that our original series, k plus 1 over k cubed plus 2, also converges because we just found out we've satisfied the hypothesis for the limit comparison test. Limit comparison test says if the ratio of their sequences goes to a non-zero finite number, then they either both converge or diverge. Since this was convergent, we can say the series we were given converges by the limit comparison test.